Hello guys and welcome. I hope that you're doing well. My name is UHD King, or I play 4K, aka I play 8K, aka I play 16K, and during this video I'm going to demonstrate Metro 2033 Redux PC game benchmark running in 16K video resolution. I'm also going to show you an extra bonus 16K video resolution gameplay in Metro 2033 Redux PC game that is using updated version of the game engine for the Metro 2033 versus the Metro 2033 Classic. But I also recorded as the first YouTuber Metro 23 PC game as Classic version in 16K video resolution and video benchmark that is available over the UHDking.com. This is going to be the world's first 16K video resolution in Metro 2033 Redux PC game. I'm going to use the Microsoft magnifier zoom tool. Let me zoom in a little bit and demonstrate for you that my desktop is set to 16K video resolution as well. In the end of this video, we're going to go through my PC hardware specification. By the way, I'm using today Unrest Elephant soundtrack provided by the YouTube, so all rights reserved. No royalties can be claimed. And let me show it to you. Display settings, as you can see, 800% zoom tool under the Windows magnifier zoom, 800%, and 15,360 pixels by 8,640 pixels, which is 132.7 megapixels, rendered in real time, and 100% scale. This is 1600% zoom as a maximum zoom, 100% scale, but this is pretty much reflection for the fonts. Only for 3% of the games then scale right under 16K video resolution when I use the 500% scale. Most it used for the fonts size. Keep that in mind. So let me open up the folder. So I'm using the Steam version of the Metro, and into the installation of the Metro folder under the Steam, it's going to be Metro benchmark.executable. Run that and it's going to be automatic benchmark of the Metro Redux benchmark. Before we're gonna go ahead and proceed, let me overclock my Titan RTX video card. Today I'm using Titan RTX video card with 24GB of video RAM, GDDR6 by Samsung, and Intel Core i9-9900K overclock at 5.3 GHz, but more about it later on in the end of this video. So as you can see, the Titan RTX running way below 700 GB per second bandwidth, which is below RTX 3080 video card, but it has the similar computing performance, but has more video RAM but delivers less bandwidth, because the video RAM on RTX 3080 video card that is using the Ampere GPU architecture, newer GPU architecture by NVIDIA, has the faster video RAM and delivers more bandwidth. It delivers 769 GB per second. Let me show you how to fix that. So we're going to match the performance of our Titan RTX at least as performance as the RTX 3080 video card in terms of the GPU running a stock RTX 3080, and in terms of the video RAM bandwidth. So pretty much I'm going to overclock my Titan RTX plus 100 MHz on the GPU and plus 1300 MHz on the video RAM under MS Afterburner tool. There is more about it. Such a video tutorial will be available over the UHDking.com, how to overclock RTX 2080 Ti video card, or how to overclock Titan RTX video card that you don't want to miss. The best possible video tutorial by UHD King. But anyways, you can see my pixel fill rate ratio increased by 10 gigapixels per second. Textual fill rate ratio as well increased by 30 gigapixels per second, and bandwidth now increase almost 800 gigabytes per second, 796 gigabytes per second, 20 gigabytes more than RTX 3080 video card at stock can deliver in terms of the video bandwidth. Alright, so I overclock my Titan RTX. Keep in mind that I already have pre-bench results of this benchmark. I already look how it's looking. Without NVIDIA Shadowplay recording, it's ready for us. Right now I'm going to bench it within NVIDIA Shadowplay recording, so you're going to witness that, and then we're going to compare the result without NVIDIA Shadowplay recording and within NVIDIA Shadowplay recording. coding. So as you can see, it's going to be 10 benchmarks. This video is not going to be as fast as possible. This video will be a little bit above 1 hour. Go ahead and grab yourself your favorite drink. The best drink will be water with a lemon, or tea with a lemon, or a coffee. I'm drinking hot chocolate with the coffee. And 10 different presets. I'm going to use all kind of different presets, as again, this is the world's first 16K video resolution in Metro 2033 Redux PC game. The world's first 16K video resolution benchmark in Metro 2033 Redux PC game. So why not? 15360 by 8640, quality at low. Textural filtering will be AF4X. Okay, this is how we're gonna start. Then 16x for those naysayers. We're gonna compare how it's running and it's dropping filtering texture quality under the Turing GPU architecture, but there is no problem since Maxwell, but for sure since Pascal, it's not even 1 FPS, maximum 1 FPS difference. Then preset medium 16x, high 16x, as again is going to only utilize DirectX 11 API under Metro 2033 Redux PC game, not like Metro 2033 original PC game utilizing DirectX 9 API and DirectX 11 API. And as again, go ahead and visit EVGA.com to see how Metro 2033 performs under DirectX 9 API in 16K video resolution. That video is already available over the EVGA.com. Go ahead and check it out, or just visit 15360 times 8640.com. It's going to be a website dedicated to 16K video resolution, 16K gaming, 16K gameplays, and 16K video resolution benchmarks by EVGA. Anyways, then we're going to use very high 16x AF. Then I'm going to use the tessellation normal. I'm going to start adjusting the tessellation, then tessellation high, then tessellation very high. Then we're going to enable the advanced physics. There is already on Turing GPU architecture a chip, so you don't need to have additional video card. It's just going to be just like additional video card. It's a chip on your Titan RTX video card or on a RTX 2080 Ti video card, dedicated chip. Since I believe since Maxwell, if not, then since Pascal for sure. So you don't need to have additional video card to advance your physics. You're not going to have any boost in terms of the performance. Maybe 1-2 FPS with additional video card, but it doesn't matter. It's going to be just a waste. Then I'm going to show you the last preset, which is the 10th preset, will be 16K video resolution, low preset, AF16X, but tessellation very high and advanced physics on, just to see how it's going to perform, kind of CPU benchmark, but with some GPU abilities to it that's going to communicate with GPU, just for those who is curious. So all kind of different sophisticated benchmarks over here, 16K video resolution in Metro 2033 Redux PC game. Let's go ahead and get going, guys. I'm coming in real time. I'm using the CPU AI noise removal from my microphone, so I'm not using the NVIDIA RTX voice removal. Don't worry about that. So it's going to ask us if we want to run it. It's going to take some time. I'm going to go ahead and say yes. Let me zoom out. And by the way, in the background, this is my wallpaper. I'm using the, as you can see, single Titan RTX video card. Okay, it says it's crashed. Do we want to use the previous presets? I'm going to say no. I just did some crazy benchmark above 16K video resolution, but it crashed. Here we go. So as you can see, wallpaper was taken with my Nikon D810 36 megapixel camera, which is the pretty much 8K UHD video resolution, and it's upscaled to 16K video resolution as wallpaper. Upscale, kind of losing some quality, but today I'm rendering native 16K video resolution and then downscaling to 8K resolution native while outputting some signal through my cable. But keep in mind that it's rendering 16K video resolution native. This is how it's going to perform natively if you're going to connect the system to 16K video resolution screen. So I'm emulating 16K video resolution Samsung screen over here, and this is what Windows 10 Professional believes and NVIDIA drivers believe. So how I did it, I modified the NVIDIA driver and I modified NVIDIA game experience to record with NVIDIA Shadowplay and Turing GPU architecture in 8K video resolution. It's possible on Turing GPU architecture, but NVIDIA introduced the 8K video resolution codec in RTX 4000 video cards. Keep that in mind. So this is without that codec, but I'm using RAM disk debugger tool, and I changed the value, and it's recording in real time, and performance in terms of the performance utilization will be the same as NVIDIA Shadowplay recording in 4K video resolution. So NVIDIA knew it's ready, but it's implemented better codec in 8K video resolution and introduced it with RTX 4000 video cards. But hopefully it's going to introduce DSR all the way to 16K video resolution before it's going to introduce RTX 5000 series. But it's ready. NVIDIA driver is ready, as you can see. So guys, Oh, it's not showing the MSI Afterburner. 1 second, guys. It's not showing the MSI Afterburner. So let me stop this benchmark right now. I'm going to escape that real quick. As you can see, I separated the benchmark with my YouTube channel right here. So the runs that I did before was without NVIDIA shell pair recording that we are about to compare. And I separated what my YouTube channel, as you can see, dual RTX 2080 Ti during GP architecture and SLI. I also have two Titan RTXs and SLI that we are about to test because Metro 2033 Redux PC game and Metro 2033 and Metro Last Light and Metro Last Light Redux supports SLI, just like Metro Exodus through some modification. Also supports SLI through the modification of the executable file of the Metro Exodus. So I'm going to test it all. I did it all, guys. All the Metro PC games in 16K video resolution anyways. So what we're gonna do, I'm going to go ahead and enable, look like we gotta enable my MSI Afterburner display information tool real quick. I'm going to enable it, and keep in mind that today is November 24th 2022. Let me use the zoom tool to demonstrate it to you. Okay, but this type of technology, so it's November 24th 2022, but this type of technology was available in the end of 2018 because Titan RTX video card was available to purchase in the end of 2018. Keep that in mind, but nobody did it, as USG King is the first 16K gaming, 16K gameplay, 16K video resolution pioneer on YouTube, and the first guys who did 16K video resolution back in 2015 on my 4 Radeon R9 290 in Crossfire, and then over this channel with 4 Titan X Maxwell GPU architecture, 16K video resolution in Half-Life 2, but before it was Counter-Strike, I believe. Source. Okay, alright guys, so what I'm gonna do, I'm gonna enable the MSI Afterburner. So I enable that. Let me zoom out now, and we're gonna start the benchmark again all over. Let me remove that for now. We're gonna see the utilization. CPU only running 6 physical cores, 6 physical threads. I disabled 2 physical cores and hyper-threading technology, which is additional 8 logical cores or threads in the BIOS. Keep that in mind. So we're gonna start from the beginning as again. Same story, same deal, but I just did a mistake. We're gonna say yes and tell us it's gonna take some time. Set yes. So now it's supposed to execute, guys, properly, and using the MSI Afterburner in place, right? Here we go. Yep, we got it. And let me disable the zoom tool. I'm using the zoom tool, as you can see, or let me actually zoom in a little bit and then disable it. I'm going to show you how the zoom tool looks like low preset 4x on the textures for those naysayers. But before we're going to do it, let me move the zoom tool to 1600% or maybe 1000% on the 16K native resolution. This is how 16K video resolution zoom looks like on low preset. Look at those level of details. This is pretty much right here 16,000. Let me bring to 16,000 percent, which is the maximum zoom right now. So 16,000% under 16K video resolution, which will be exactly 4K video resolution, because 16 4K resolution screens is equal 1 16K video resolution screen. Keep that in mind. So this is exactly, if I'm going to zoom in into the 4K video resolution, we can see all those pixels, and this is under low preset. This is unbelievable. This is without the details. Artificially right now, the game engine for a game engine by the 4A Game Studio from Ukraine is pretty much artificially decreasing level of pixels, but under 16K video resolution we're probably loading all the pixels out of the texture anyways, but just to in case, it's still artificially decreasing. I'm going to check it out, guys, under the 16K video resolution, and we're gonna check it out. Let me zoom out. Here we go, and let me zoom out. We're gonna check it out how it's going to look under the very high preset. just to see the difference in terms of the pixels. But you saw that little 1/16 of the 16K video resolution screen. It's 1/16 little area. It was so detailed. If you're going to look in that area 1/16 in under 4K video resolution as your game set to it and your desktop set to it, under 1600% zoom tool under the Windows magnifier application, it's going to be so blurry, guys. The amount of pixels, not even close what you saw. You're not going to recognize what you're seeing. Actually, you're not going to see any details if you're going to zoom in 1600% through the Windows magnifier zoom tool under the 4K video resolution game resolution set to or desktop set to as well. Everything will be so pixelated and such, but you saw so beautiful. The pixels was so there, and this is pretty much just was the area that covered by the 4K video resolution in terms if you're going to compare to 16K video resolution. Just 1/116 of the screen, which is 16 times of the 4K resolution screens is equal 1/16K video resolution, or 4 8K video resolution screens is equal 1/16K video resolution screen. Keep that in mind. Okay, this was the low preset with the 4x anisotropic filtering, the lowest possible texture quality possible. I showed you under the zoom. We ran 3 benchmarks. I'm going to do 3 benchmarks just at least, just to make sure that we're gonna get the right averages. And if we're gonna see any mistakes, we're gonna capture the mistakes. And also the other reason, because when I'm going to run high and very high preset, it's pretty much going to preload the shaders through first benchmark. It's pre-compiling, pre-caching the shaders. Keep that in mind. Alright, as you can see, sometimes the GPU utilization jumping like 58%, 60%. I saw it for a couple seconds. It happens only in Metro 2033 Redux PC game under low preset and under medium preset. And I believe this updated game engine for the Metro 2033 that powering Metro 2033 Redux PC game is pretty much using same CPU classes. This is why it happens, those depth. While Metro 2033 PC game, the original one, under low preset and medium preset under 16K video resolution was constantly 99-100% utilization, or at least 99%. Keep that in mind. It never jumped into 60 or even 70. So Metro 2033 Redux PC game is not utilizing well under low and medium preset in terms of the GPU utilization. Even under 16K video resolution, sometimes in jumping to 50 and 60% in terms of the GPU utilization. Okay, keep that in mind. But Metro 2033 classic PC game has no problem. Both games supports SLI because it's supporting DirectX 9 and DirectX 11 API for Metro 2033 PC game, and Metro 2033 Redux PC game supports only DirectX 11 API, and I also believe it supports SLI. But I'm going to test it. 2 Titan RTX video card in SLI. This is the first video card that allow us guys to run, not enterprise version, also RTX 6000 and RTX 8000 Quadras, which was powered by Turing GPU architecture, but RTX 8000 Quadra was featuring 48GB video RAM, but it was only for enterprise. But this is the gaming that gamers can get, and the first video card. So this is going to be the first vertex, the first coordinate in our 16K video resolution benchmark in Metro 2033 Redux PC game that we're going to use in the future while we're going to test the future GPUs, the future CPUs, and future PC systems, and even mobile systems, guys. Keep that in mind. So it's a great benchmark. It's, as you can see, the 4A games game engine is a great overlay over DirectX 11 or DirectX 9 API without any issues, without any limitations. So it's a great game engine, and it has no problem all the way to 16K video resolution as Metro 2033 classic PC game or Metro 2033 Redux PC game. So we're going to use it in the future, guys, a lot, especially when we're going to benchmark 8K video resolution, 16K video resolution. I believe the game engine through the gameplay is limited to 200 FPS, but throughout the benchmark it's unlocked. So this is going to be, guys, right now I believe the medium preset, if I'm not mistaken. We just saw Yeah, this is the medium preset. No, this is a high preset because medium preset. Yeah, this is the medium preset. So we saw already two low presets, 4x and 16x. This is the medium preset. The FPS will be 2-3 FPS higher in Metro 2033 Redux PC game versus the Metro 2033 original PC game. And the reason is because they're using updated game engine, but I believe they cheated a little bit and they're using the different shaders and even different 3D models with, I believe, maybe sometimes even with less polygons, but they had the better 3D artists that did the better job on low polygons and consuming less polygons, but it delivers a little bit higher FPS or better optimization, but it at least delivers 2-3 FPS higher than Metro 2033 classic game engine. But sometimes in Metro 2033 classic game engine, some elements looks better than the Metro 2033 Redux PC game. Keep that in mind, in my taste. But again, it depends to your taste. I have both. Games, licenses, every single Metro game, licenses on multiple platforms. I'm supporting the 4A games developers from Ukraine. I advise you to do it as well. Their talented 3D animator died. Andriy Korzynkin, he was fighting. He died in September 2022. He was fighting with Ukrainian army against Russian army, against fascists, against those bandits from Russia, and he died. He was killed in September 2022. So Metro Exodus games will change, guys, will be changed in the future. This was the message by his friend that no longer working for 4A games, but he's working for a Western company as a game developer, and he wrote this in October 2nd to in October 3rd, I believe, 2022, that he was killed. So Metro Exodus game, the next part of the Metro will be changed because he did a great animation in Metro Exodus. He was the main 3D animator. So condolences by UHD King to 4A Games and anybody who knew, friends, family, the Andriy Korzynkin from Ukraine. Was fighting for Ukraine, died for independence, and died as a hero. Okay, guys, so third bench, medium preset. If it's going to run 2 Titan RTX and SLI, it's going to be way above 40 FPS in Metro 2033 Redux under the medium preset. And this is amazing because the medium preset, even the low preset in 16K video resolution, looks like so crazy, guys. It looks like 4K at very high preset. Look at this, the level of details, everything is so amazing. Hopefully I'm going to demonstrate you as additional bonus without the cutout by NVIDIA Shadowplay because I'm running out of space right now on my hard drives. I'm going to show you the gameplay as well as a bonus, and you're going to see how beautiful the game looks under 16K video resolution. It's just unbelievable. Even under medium preset, it's just unbelievable, guys. As you can see, this is, I believe, a very high preset right now, and as you can see, the maps are building. The texture is building through some different maps like normal map, diffuse maps, occlusion maps, and you can see how it's building, how the game engine using the post effects while it's building its graphics. That 4A games game engine that was built in the house by 4A Games Ukrainian studio. And yeah, this is very high, you can tell by the FPS. And this is the first run, but still great FPS, above 10 FPS average while recording with NVIDIA Shadowplay. And I cannot wait to test with 2 Titan RTXs and SLI. Is it going to be playable and very high? If it's going to be playable under 16K video resolution with 2 Titan RTXs, or even at high I think it will be playable, the playable status, not benchable only status, but playable status. I think it's going to be above 30 FPS at high preset, but cannot wait to test it. If it's going to accept the SLI, guys, if 2 Titan RTXs will support SLI under Metro 2033 Redux in November 22. If it was before, it's supposed to. I don't remember if Redux version Metro 2033 supports SLI. If not, if it's going to support SLI, I'm going to demonstrate SLI over the UHDking.com or over the 15360 x 8640.com website, as again that's going to be dedicated to 16K video resolution, 16K UHD, 16K gaming, 16K gameplay, and everything about 16K video resolution, guys, by UHD King. Alright, so as you can see, GPU utilization now 100%, 99, 100%, excellent GPU utilization. We want to keep our GPU utilization 99 and 100%. 100% GPU utilization, it means every single CUDA core is utilized. We're utilizing every single performance squeezing out of our Turing GPU architecture, in our case TU102 full GPU that's powering the Titan RTX video card and helped by additional video RAM, which is 24 GB by Samsung GDR6. There is also overclock additionally by 1300 MHz, but just because of GDR6 under MSI Afterburner, you gotta multiply it by 2, so additional overclock by 2600 MHz output as external frequency. And as you can see, video RAM utilization almost 18,000 megabytes at the left top corner. As again guys, there's data at the left up corner, self-explanatory, but we're gonna go through it. And system RAM utilization below 11,000 megabytes. So system RAM utilization is about 700 megabytes below than it was under 16K video resolution in Metro 2033 PC game benchmark. Go ahead and check it out. As again, check the video comments in this video or video description. I'm going to include that video. So this game engine is actually performing better in terms of the FPS. And in terms of the visuals, I really like the Metro 2033 Classic, to be honest. Okay guys, so as you can see, very high preset right now, and I believe it's tessellation at normal right now. So before we were running tessellation off, right now tessellation normal or tessellation high. We're gonna check it out. There's going to be 3 benchmarks. And as you can see, it's slowing down, but tessellation in Metro 2033 Classic PC game or tessellation in Metro 2033 Redux PC game, no problem for the Turing GPU architecture. So it's going to be even faster on Ampere GPU architecture, such as video card RTX 3090 or RTX 3090 Ti, or under the EVGA GPU architecture video cards such as RTX 4090 or RTX 4090 Ti. It's going to be even faster than that, keep that in mind. And it's only possible and runnable, this benchmark, on the video card by NVIDIA technology that has on board 24 GB of video RAM or more. Otherwise, you're going to be overload your VRAM, you're going to offload a lot of data into the system RAM, the game can crash or not going to show the performance out of your GPU if you're going to run the benchmark on a video card with less than 24 GB of video RAM. Even if your GPU performance will be faster than Turing GPU architecture TU102, let's say either GPU architecture from video card RTX 4080 video card, but 12 GB or even 16 GB of video RAM will be not enough for NVIDIA technology on any video card even in 2023 to run this benchmark in 16K video resolution. Maybe in 2027, when they're going to introduce the better rate of compression rates and is going to pass a lot of generation, like at least 4 generation of the new GPU architectures, maybe it's going to utilize in 16K video resolution with a much better way of compression, textures and data into the video RAM. Maybe it's going to utilize like 16 GB of video RAM, but I bet it's not going to cut 10 GB of the video RAM usage through the compression. I think we are already pressing that compression algorithms to the best possible results that is possible with the Turing GPU architecture. Maybe ADA going to be a little bit better in terms of the compression by a couple percent, but couple percent. It's not even going to be better by 20%, keep that in mind, in terms of the data compression and how much VRAM it's using in the same type of the scenarios. So it's still going to be in need of video card with 24 GB of video RAM for NVIDIA GPU architecture, and AMD video architecture and GPU architecture using less video RAM, keep that in mind, under the same resolution than NVIDIA. So for the AMD video cards, maybe possibility that 16 GB of video RAM will be enough, but as again, questionable. This is a serious resolution, 132.7 megapixels rendered in real time. So this is the last benchmark. Let's go ahead and check it out, what kind of benchmark we are running. Let me use the zoom tool. So under the zoom tool, we are running, guys. Wow, I can feel that lag. The system is stressed on the maximum. We are running, guys, very high preset, AF16X, tessellation off, advanced physics off. So this was just very high preset that we just finished. Okay, so right now we are going to run, let me zoom out. Right now we're going to run very high preset and tessellation at normal. Right now this is the test, and it's going to be 3 benchmarks, and then very high preset and tessellation at high, and then very high preset tessellation at very high, and then very high preset tessellation very high and advanced physics on, and then I'm going to switch to low preset, visual preset, and the tessellation very high and advanced physics is on, and it's going to be the 10th test. And then we're going to compare the data without NVIDIA Shadow Play recording, and within the Shadow Play recording we're going to talk about my PC configuration in depth, and I'm going to wrap up with this video, guys. So coming to the wrap up, a lot of data is about to be exposed, but you can already see what's going on. As again, this is the first vertex or the first coordinate for 16K video resolution benchmark in Metro 2033 Redux PC game, and this is the first video card that's capable to do that. And of course it's not delivering the playable experience, it's understandable, but this is the first vertex in our vector direction towards the 16K video resolution benchmarking. Keep that in mind, and we're going to use it in the future a lot. Alright, so right now look like the share is precompiled. And it's absolutely beautiful under the normal tessellation. And what is the tessellation? Tessellation is when the algorithm is splitting some polygons. So 3D models, you can see it as an object, but they modify it through the polygons. So tessellation is splitting one polygon into multiple polygons. It depends on the algorithm, and I believe under normal maybe it's splitting into 2 polygons, so it's double of terms of the polygons, maybe for the characters and some areas of the level design. Maybe very high is maybe even 4 times in terms of the polygons count, or 3 times. I'm not sure. Maybe it's 1.2 times more polygons, 1.5 times, and 2x on the very high. We never know what the game developers use, as 4A games developers use in their algorithms for the tessellation. But as again, this is splitting polygons, so you gotta understand that. Okay. As again, the Metro 2033 Redux PC game is not using any ray tracing, so we only utilizing the CUDA cores today. The old school classic rasterization CUDA cores that is responsible for rasterizing the graphics right now while using the 3D real-time rendering API, which is DirectX 11 API by Microsoft. Okay, let me have a look at the zoom real quick while it's doing that. So it was the very high preset AF16X tessellation normal, I was right, and without advanced physics. So okay, so right now it's running actually tessellation at high. So this is going to be the first run, so it's still pre-compiling the shaders. Then it's going to be the second run. As you can see, it's getting heavier and heavier, so GPU is not capable to pre-cache the shaders in real time, even through first run, complete first run. This is how long it takes, while it's at the same time rendering the game. So it's doing 2 tasks in parallel, pre-caching the shaders and it's rendering the game. It's very heavy under the 16K video resolution, even for Turing GPU architecture. So hopefully the EVGA GPU architecture with RTX 4090 video card can deliver at least 3 times performance, at least over Turing GPU architecture. This is a minimum, but on average 3.5, 3.7 times as minimum. And hopefully we're not going to see those pre-caching. It's going to be done in real time, but we're going to find out, because the EVGA GPU architecture in video card RTX 4090, the second level cache on the GPU, which is outside of the streaming multiprocessor unit or block, which is storing some amount of CUDA shader cores, and the whole GPU is built up of those streaming multiprocessor blocks or units that have inside CUDA streaming cores. So share cores. So pretty much it's using the share level second cache on every single streaming multiprocessing blocks or units, while level first cache is using dedicated to streaming multiprocessor unit or block for exact amount of the CUDA shader cores. So the level second cache on either GPU architecture is almost 6 terabytes per second. This is how fast it is in terms of the bandwidth. 6 terabytes per second, while the level second on the Turing GPU architecture through the micro benchmarking tool that's using CUDA and Open and C language, those type of benchmark, I was reading some information from a computer scientist while I was developing the CPU and GPU ray tracing benchmark. I'm still developing that. So the Turing GPU architecture second level cache will be, guys, 1.5 terabyte per second. This is how fast it is. So either GPU architecture in RTX 4090 video card is almost 6 terabyte per second, second level cache. This is how fast it is. On Ampere GPU architecture, second level cache will be 3.2 terabyte per second. Keep that in mind. While the video RAM on Ampere GPU architecture on RTX 3090 or RTX 3090 Ti video card is only 1 terabyte per second bandwidth. Today my bandwidth is almost 800 gigabytes per second, while my second level cache bandwidth is 1.5 terabyte per second. So video RAM almost 800 gigabytes per second, and second level cache is almost 1.5 terabyte per second. I'm not sure how fast the first level cache, which is the fastest video memory on the video card, which is located exactly on the crystal and on each streaming multiprocessor units or blocks. But I explained to you how fast the second level cache on Turing GPU architecture, Ampere GPU architecture, and EVGA GPU architecture. So this is an extra information. But EVGA GPU architecture featuring 72 megabytes of second level cache, 72 megabytes of second level cache, where Turing GPU architecture is only featuring 6 megabytes of second level cache. Keep that in mind. So it's featuring like unbelievable amount of this second level cache. I cannot wait to test RTX 4090 video card in this benchmark, guys, on the 16K video resolution. It's going to be a king. And keep in mind that AD102 GPU is not fully featured on RTX 4090 video card, because the full second level cache on the AD102 GPU on full GPU will be 96 megabytes of second level cache. And also the streaming multiprocessor units on the AD102 full GPU is 144 of them, which will be split. Every single streaming multiprocessor unit will have 128 CUDA cores in them. And while, guys, the RTX 4090 video card is only featuring 122 streaming multiprocessor units. So there is 22 more streaming multiprocessor units out there. And I think they're going to introduce the RTX 4090 Ti video card as again, or next Titan video card. Hopefully it's going to be Titan King or something like that, but hopefully they're going to introduce 48 gigabyte of video RAM GDDR6X on it, because otherwise we're not going to expose fully EVGA GPU architecture, because EVGA GPU architecture at least needs to have 48 gigabyte of video RAM. It could be GDDR6X or could be faster than that, but there is no such a technology as that faster than GDDR6X that introduced on either right now at the moment, and I think it's going to be GDDR6X, but they must introduce 48 gigabyte just like they introduced an enterprise video cards since the Turing GPU architecture in Quadro RTX 8000 video card, which is pretty much the same video card as Titan RTX, just like Quadro RTX 6000 video card, the same video card as Titan RTX, only Quadro RTX 6000 video cards is using registered GDDR6 and Titan RTX is using unregistered unbuffered GDDR6. This is the difference, while you cannot flash the BIOS, but everything else will be the same. The difference will be GDDR6 register on the Quadro RTX 6000, while Titan RTX unregistered unbuffered GDDR6, and RTX 8000 same Titan RTX, but will be featuring 48 gigabyte of video RAM GDDR6. And come on, NVIDIA, introduce for the gamers gamer video card with 48 gigabyte of video card, so we can experience that with the RTX 4090 Ti, or maybe the newest Titan video card that's going to be based on EVGA GPU architecture that NVIDIA will introduce in 2023, because as you can see, we have the potential, as I just explained to you while I was studying the EVGA GPU architecture, while I was doing the GPU retracing and CPU retracing, and was studying a little bit of CUDA manuals for the C by the NVIDIA. Anyways, guys, right now we're running the very high preset, distillation very high, but without the physics. And right now it's running within the physics, but let me use the zoom. I want to show you under the zoom how right now it's pre-caching, but next one will be already pre-cached. Let me use the zoom, maximum zoom, which is 1600%. And let me bring that zoom. 1 second, guys, just to demonstrate for you that zoom. Look at this. This is their thing. That's 1600%, and my font will be crystal sharp. But 1 second, guys, it's rendering, as you can see. Let's go ahead and something here. Oops, it quit the benchmark. Hopefully it didn't crash the benchmark on us. What happened there? Close the benchmark. Something happened. It crashed. So only ran 4 FPS. So with the physics on, only ran 1. Let's go ahead and try it again. I'm not going to mess with the zoom. I tried to use the zoom to show you how beautiful it is, but I guess I'm going to show it to you when I'm going to run the game. Let me go ahead and run the benchmark again, that portion of the benchmark. So we're gonna. So it was the last one, which advanced physics on, tessellation very high, textual AF16X. Hopefully it's still recording, guys, because it could terminate my recording very high. Something happened. Hopefully it's not a problem with the driver there. So okay, so I'm just going to run those 2 benchmarks and we're gonna complete it. So I'm gonna run this one and this one. Run selected, so I'm gonna run selected. Then I'm gonna run the second one as well. So this is selected. I'm gonna mess with the zoom tool. We're gonna have that separator. I remember only one benchmark that did. So tell us, okay, do you wanna run? It's gonna take some time. I'm gonna say no. It's actually asking the safe mode. We're gonna say no to the safe mode. And it's gonna start the benchmark. Okay, so this is the heaviest possible preset. I already benched the heaviest possible preset while I was recording. This is the second recording, so don't forget to smash that like button. I'm re-recording. It was frozen on me on the third stage, third run under this preset. So that's probably why it terminated the game. Maybe there is something crashing there. There is DirectX 11 API error or something, and it's not passing it and crashing the runtime of the game engine. Possibility. Okay, but as you can see, it's still pre-caching the heaviest possible preset, and now you can see it's through the maps. It's generating the final textures, but still generating through some maps. It's not done yet, but as you can see how the post-processing effect works under the 4A game engine. You can analyze that pretty well, especially if you're a professional game developer or software developer. You can see the processes, what kind of processor is going on in real time. So pretty much right now we're baking the textures throughout some maps. Okay, it's crashing. So it doesn't like that because advanced physics on. While I'm running the NVIDIA Shadow Play, it doesn't like that. Alright, it was also didn't like some presets under Metro 2033 Classic. So while you're recording under 16K video resolution in 8K video resolution while using NVIDIA Shadow Play, look like it's stressing some components that Metro 2033 Classic PC game and Metro 2033 Redux PC game was using, and some preset is not running, the most heaviest preset. So we're gonna skip on that. We saw the FPS, it was compiling, and when it didn't finish the compiling, it's crashing because the DirectX 11 API error, most likely, and it's not passing that error, it's terminating the runtime game engine application. Anyways, let's go ahead and run the last preset, which will be lowest possible preset, very high tessellation, advanced physics is on. Just to compare how we did the second lowest possible preset, but without advanced physics and without the tessellation. Let's go ahead and have a look how it's going to behave under this type of conditions. But as you can see, the game is terminating, and it's recognizing that the game engine is terminated by the log file, and it's asking us, do we want to run the save mode? Of course not. And I'm going to say no, and we're going to execute it. So this is the lowest possible preset with combination of the heaviest possible preset in terms of the multiplying the polygons in the 3D mesh or 3D models. I'm not sure exactly where they're multiplying them. I believe most likely in 3D characters, because this is where you want to see that detailed character 3D mesh. Maybe in some portion of the levels as again. but this is low preset. As you can see, in terms of the FPS, from above 22 FPS, we went like below 20 FPS because the tessellation and advanced physics in combination. So we lost, I would say, about 4 FPS, but we're gonna study it. Throughout the tessellation at very high, which is the maximum possible tessellation possible, maybe splitting one polygon into two on the very high, we never know. Maybe normal 1.2, high 1.5, and maybe very high 2x. So one polygon split it exactly into 2 polygons possibility, or maybe 3 polygons or 4 polygons. It depends on their algorithms. As again, I know under 3ds Max Studio, when you're using the tessellation, you can set that multiplier, and you know exactly by how much your polygon split it. And it crashed as well. Sounds like it's crashing under very high tessellation and advanced physics. It doesn't like it. It crashed even the low preset, and I'm not sure why it did it. Somehow it doesn't like it. Maybe it's the game engine doesn't like those type of preset under 16K video resolution, because 16K video resolution is the maximum video resolution on any commercial or open sources 3D rendering, 3D real-time rendering APIs. As again. So okay, let me remove the advanced physics. Let's go without it, but very high tessellation, low preset. Let's go ahead and try to run this type of preset as 12 benchmark, just to have a look. I never benched it before, but let's go ahead and have a look how it's going to perform. I'm just curious. I think maybe advanced physics with very high tessellation under 16K video resolution too much, but as again, it was no problem without NVIDIA Shadowplay recording. So I'm assuming that NVIDIA Shadowplay software, while utilizing the hardware, probably utilizing the same hardware components that Metro 2033 and Metro 2033 Redux PC game did throughout that benchmark. There is a possibility, this is how I'm assuming, as hardware enthusiast, PC overclocker, and software developer, game developer, as first ways of the troubleshooting what's going on. Okay, I just explained to you the way of analysis, but as you can see, in terms of the video RAM utilization, we still like 5 GB to go as minimum. We can load some more data into video RAM, and system RAM utilization still below 12,000 megabytes, so we're not offloading any data into system RAM, and healthy VRAM utilization. So I'm not sure, maybe it just advanced physics together with very high tessellation under 16K video resolution while it's using NVIDIA Shadowplay, as again, doesn't work well. But without NVIDIA Shadowplay, I'm going to show you how it did it. So we're going to compare it. I did it successfully without it, keep that in mind, as I remember it. But let's go ahead and have a look. So this is the, I'm going to go ahead and do one more test. I'm going to set the medium with the tessellation maximum. So pretty much under 16K video resolution, is for sure looks like 4K resolution, very high visual preset. But I'm going to use the medium preset, 16K video resolution, and tessellation very high. So pretty much in terms of the polygons count in the game, in the 3D world, is going to be the same as very high preset. And tessellation very high, but in terms of the texture quality, but as again, just because we're rendering 16K video resolution, I think we're gonna bypass that artificial limitation in terms of the pixel count. We're still going to deliver more pixels, and the visuals will be great, because right now the visuals is unbelievable, and this is low possible preset. The quality of the pixels and quality of details of the low possible preset is unbelievable. It's running very nice, guys, without the advanced physics and tessellation, and very high. So maximum possible polygon throughout the 3D rendering in real time present right now, guys, just like we did at very high preset with very high tessellation. But in terms of the pixel count, maybe we're not delivering, we're blurring them out, even if the resolution is 16K, but maybe in terms of the level of details through the artificial algorithms, it's limited by the game engine at the low preset. That's why it's the presets. Alright, so imagine RTX 4090 video card has 16,364 CUDA cores. It's the same, guys, CUDA cores count as my width in terms of the pixels I'm running right now. This is just unbelievable. That RTX 4090 video card is crazy. The next video card after RTX 4090 video card, like RTX 4090 Ti, even with the EVGA full AD 102 GPU, will be, guys, crazy blown video card. And the next one, RTX 5000 series, will be probably your last video card before PC gaming will be dead, and you will switch to mobile gaming and the AR gaming with the mobile devices. Anyways, we just bench it, and before we're gonna look at the results, let me zoom out. Let me bench one more time as I promised to you. Let's go ahead and do one more time. I didn't pre-bench those type of results. This is going to be an extra for you, medium preset, because it's going to look definitely amazing. I just want to see the FPS. This is for those who's curious how the CPU in terms of the GPU reflection. This is going to be a great test in combination. So I'm going to run this benchmark 3 more times, and I just want to see the GPU utilization, because when we were running medium preset, the GPU utilization sometimes was jumping to 58% load and even 60% load just for a few seconds. But let's go ahead and have a look if it's going to be the case right now. Yep, 53%, 45% is still doing it, even when tessellation very high. So even tessellation very high is not utilizing the full GPU utilization under the medium preset in Metro 2033 Redux PC game under even 16K video resolution. It's not the maximum stress on the GPU on all the Turing GPU cores on the TU102 GPU, which is the flagship under the Turing GPU architecture by NVIDIA, in the video cards such as Titan RTX. Some people saying RTX Titan, but the proper name is Titan RTX. Keep that in mind. RTX Titan video card, there is no such a video card like that. The proper name is again Titan RTX video card. Alright, so yeah, still great FPS. It looks great, guys. Let me show it to you after the second test one with the precompile shaders. I'm going one is going to run the third test. I'm going to show you with the Windows magnifier zoom tool how great it's looking under 16K video resolution medium preset with tessellation very high. It looks, guys, great. It looks like 4K resolution very high and everything, including the tessellation and visual preset. This is how it looks. The level of details right here is just unbelievable. And as again, cannot wait to test with 2 Titan RTX video cards. But believe me or not, RTX 4090, you gotta at least 3x that FPS. So it's going to be 30 FPS at least on RTX 4090 video card. But in most cases, I think when the GPU is utilizing on that RTX 4090 video card at fully, I think it's going to deliver 3.8x or even 4x when you're going to overclock your EVGA GPU architecture RTX 4090 video card, guys. In terms of the video RAM, we're going to be limited in terms of the video RAM on that RTX 4090 video card, because 24GB is not going to unlock the full potential of the GPU. So we cannot run the games that we can based on GPU performance, power, computing calculation performance as a result, but we're going to be limited bottleneck through our video RAM. So as again, that's why we need to have 48GB of video RAM, and I think NVIDIA will introduce in 2023 EVGA GPU architecture that will feature the full ED102 GPU. It's going to be RTX 4090 Ti or new Titan, hopefully Titan King, with 48GB of video RAM, guys. Remember that GDR6X, 48GB video RAM. ED102 full GPU is coming in 2023. Smash that like button if you're watching it in 2023 and my prediction came alive, and yeah. But RTX 5000 video card is going to be your last video card for PC gaming before PC gaming will be dead in 2025. But enthusiasts still going to play it like those they play Nintendo and Sega games, but everybody will be switching to mobile games and AR mobile game experience through the glasses and all kind of different devices and the holograms. Okay, so we did this test, so pretty much that's it. So what we're gonna do right now, we're gonna study the data. Okay, so I'm gonna show you the data. Let me zoom out. We're gonna study the data first, and we're gonna study the data that was without the recording. So please watch this video as again, switching your YouTube player to 4320p or 8K UHD, because it was recording in 8K UHD. I'm going to upload an 8K video resolution without additional, guys, manipulation or editing with this video. As again, single cut, single take of this video, coming in real time, and experience as it was experienced. So this was, guys, 4x 16K resolution, low preset, everything off. 22 FPS average, great result without the recording. with NVIDIA Shadow Play, and this is going to be 16x. So from 22 FPS we went to 21 FPS, not even 1 FPS difference. So anisotropic filtering in terms of the texture quality doesn't matter, 4x or 16x. If you're playing on a video card, Turing GPU architecture or new video cards, GPU architecture by the NVIDIA, go ahead and smash it to 16x. It doesn't matter in terms of your video RAM, and it doesn't matter in terms of your, in terms of the video, maybe it's matter like in terms of 500 megabytes maybe, as you're gonna rewind the benchmark and have a look, but in terms of the FPS it doesn't matter. Alright, so this is going to be the medium preset, 16x, 16K video resolution, and 16x anisotropic filtering, but everything else is off, 20 FPS. Great result. 2 FPS only the difference between the low and medium preset. Not even 2 FPS. A little bit lower than 2 FPS. This is unbelievable performance on a Turing GPU architecture Titan RTX video card. Alright guys, so high preset and anisotropic filtering 16x, 16K video resolution, 11 FPS average. So this is without the recording. Very high preset without the recording, 16x anisotropic filtering, everything else is off, 4 FPS average. So almost 5 FPS average, as you can see. I would say probably without the recording. This is without the recording, so within the recording still going to be 4 FPS. There's not I would say 4 FPS average, keep that in mind, 4 or 5 FPS average. So this is without the tessellation, without advanced physics. Now with the tessellation normal, very high visual preset, 16K video resolution, anisotropic filtering 16x, and almost 5 FPS. Not such a big difference between the tessellation normal and tessellation off. At very high preset. So for Turing GPU architecture it doesn't matter. The visual preset actually what was the matter, but tessellation doesn't matter for Turing GPU architecture in such a game such as Metro 2033 or Metro 2033 Redux PC games. This is what I learned throughout the experience and throughout the benchmarks and the data analysis. Alright guys, so very high preset, AF 16x, tessellation high, almost maxed out tessellation, 16K video resolution, still 4 FPS average, not big difference. Now tessellation very high preset, AF 16x, physics is off, still 4 FPS average, not a big difference. So I don't think the tessellation is gonna bring on very high to, maybe it's going to bring at very high 2 polygons versus 1 polygon. I think how it works, it doesn't apply to every single polygon. It applies, as again, as I told you, to certain 3D models, certain polygons, okay? Probably in 3D characters, 3D models, which is representing the characters in the game, so they're gonna be more modified as 3D mesh through the tessellation, because tessellation is almost to the polygons, to the 3D mesh. It's not to the textures and such. Anyways, guys, and it's built-in classes of DirectX 11 API built-in, so developers just use that. But the way they utilize, we never know. Very high preset, 16K video resolution, AF 16x, tessellation very high, advanced physics is on. This is without NVIDIA Shadow Play recording, and FPS still 4, but very low 4 FPS average, okay? Now, we're gonna do the low preset, AF 16x, tessellation very high, and advanced physics is on. Without NVIDIA Shadow Play recording, still benchable, and FPS will be high. As you can see, 17 FPS average. Great result, great result. And it's not benchable, as you saw within the while we're recording with NVIDIA Shadow Play. All right, this is a separator, my YouTube channel, okay? And let's go ahead and switch to, now this is within the NVIDIA Shadow Play recording. So low preset, 4x AF, everything else is off. 27 FPS average, wow. But as again, there was mistake on the second test. That's why I'm running 3 tests. This is very important, especially in this particular game, because as you can see, because it's caching the shaders in real time, sometimes benchmark through 1 run or even 2 runs, not going to show the proper FPS. But as a human being, we can analyze and we can correct. So 21 FPS, I would say. Same, pretty much the same deal. Okay, on average. And this is going to be the low preset 16x, including the NVIDIA Shadow Play recording. Everything else is off, 20 FPS average. So we lost like 1 FPS while I'm recording with NVIDIA Shadow Play throughout this benchmark under 16K video resolution scenario. Keep that in mind. So at 1 FPS while recording with NVIDIA Shadow Play to the FPS to find out the FPS without the recording. Pretty much that's it. Medium preset, everything is off. AF 16X, 19 FPS average. High preset, everything else is off. High visual preset, 11 FPS average. Very high preset, everything else is off. AF 16X, and of course 16K video resolution, 5 FPS average. Makes sense. Then tessellation normal, 16K video resolution, AF 16X, preset very high. Advanced physics off. 4 average FPS, almost 5, just like it was without the recording. So NVIDIA Shadow Play is again 3% of the taxing on the GPU performance, which is amazing. NVIDIA Shadow Play is the best video recording software in real time, guys, that you can imagine, because it's utilizing hardware and software, and hardware utilization through the hardware acceleration is the key for the video capture. Keep that in mind. And especially RTX 4000 video cards, RTX 4090 video card is the best video card because it can record in real-time 8K video resolution. There is, to buy just a video card that's capable to do that will cost you above $2,000, and this is just a bonus for your video gaming card. The NVIDIA is just a magician company. Jensen Huang is just magician, guys. So 4 FPS, very high preset visual, tessellation high, 4 FPS average. And then tessellation very high, physics is off, still benchable, 4 FPS average, still 4 FPS, not below 4 FPS, which is great news. And then we use the very high preset, tessellation very high, but physics is on, and it only ran one benchmark while we're compiling the pre-caching the shaders, and then it crashed, and I think because it was generating some DirectX 11 API error or something like that. I was studying the logs, and that's why it crashed. Okay. You can make sure it's not going to crash on that, but you got to use some applications, some tools that are going to intercept the calls of the DirectX 11 API running in real time. But I didn't do that, as again, game was running completely stock, everything was running stock. Then we did the low preset with tessellation very high and advanced physics on. While recording with NVIDIA Shadow Play, it's also crashed. Didn't compile it right, even on the first stage of the benchmark or first trial. Then we did the low preset, very high tessellation, and advanced physics was still on. I did it again, it crashed as you can see, but low preset. And then we did, guys, low preset, tessellation very high, but advanced physics is off, and it showed 17 FPS, very great result. So low visual preset, tessellation very high, maximum in terms of 3D meshes quality, but textures was not the best, but under 16K video resolution is still as good as 4K video resolution, even at the low preset. Great result, 17 FPS average. And this is the last test that I did. Medium preset, very high on tessellation, and advanced physics is off. Average preset was 16 FPS, which is great result, guys. All right. So pretty much we just analyzed that. We're done with the analyzation. Hopefully still recording. I believe so. And just because this is the world's first 16K video resolution benchmark, 16K gameplay and 16K gaming, I decided to go ahead and give you away a game, guys. It's not going to be a Metro 2033 Redux PC game, but I'm going to give you away another interesting game. It's not going to be first-person shooter. It's going to be RPG, but it's going to be like Fallout RPG, but in game engine and game developers that develop it and release it in 2020. It's a value at least $10. The game going to call full game is going to be Atom, RPG through the GHz PC game. It's going to be for Steam client. This is UGK gift to celebrate the world's first 16K video resolution benchmark in Metro 2033 Redux PC game. This is the code that you gotta use under the Steam. Where's my mouse cursor? The mouse cursor is such a small. Right here to activate the game. Please go ahead and do that for those who's watching on the mobile devices. This is the code for you. Go ahead and use this code to activate the game. And to the first activator, please let us know who you are. Just do not say your full name, just state your nickname and say I activated the game, or just state it I activated the game. Thank you so much, just to let us know so people don't, if somebody is activated, it only can be activated once. It's a one legal copy, guys, and prepaid copy for you. Otherwise it's not going to be activated. It's gonna let you know that somebody is activated. But if you that somebody that activated the game, please let us know in the video comments down below. Alright guys, right now I'm going to do the bonus for you, and it's going to be the bonus for you, and we're going to run just the gameplay. We're gonna run just the gameplay. Let me go ahead and execute the game. Let me make sure that I disabled my zoom tool, and we're going to run the game in the windowed mode. Here we go. The Metro 2033 Redux PC game has no problem to run the game in windowed mode, but Metro 2033 PC game, which is the classic original game, is after the benchmark is rewriting its config user.cfg file, and is enabling the full screen at on, even if you're going to set it to off. In Metro 2033 Redux PC game, even when you're going to switch the presets, it's still going to keep that windowed mode, which is nice. So it's great because it caught on me when you're gonna watch that video of Metro 2033 PC game. It caught it in the middle of the video recording, and I'm apologizing, but I did everything what I tried to do throughout the video. It was just additional 5 more minutes, so we're Gucci there. So it was rendering, it was the video, it wasn't in real time. That's why the GPU utilization was kind of low. So now we're gonna go ahead and start the game. I'm going to start the first level, and we're going to start with the preset, which will be 16K video resolution, very high, DirectX 11 without any anti-aliasing. Keep in mind that I can use the anti-aliasing, but under 16K video resolution on Titan RTX video card equipped with 24 GB of video RAM, it's offloading a video RAM and crashing the game completely on the first trial of the benchmark. Okay, and it's running not even in real time. The video RAM overload is like at least 5-6 gigabytes into the system RAM, while it's using like 23-24 gigabyte of video RAM. Keep that in mind. So it's not possible. I'm not gonna try it because it can stop the video recording, but I'm going to show you all kind of different presets. Let's go ahead and start with the lowest preset, but we're gonna start with the low preset, 16K video resolution, DirectX 11, of course, and I'm going to accept that. Hopefully it's going to accept it in real time. Nope, it doesn't do. Still, Metro 2033 Redux PC game doesn't want to bring the game into the windowed mode, so it's going to bring it into the full screen mode. Right now you can see the black screen, but for me it's flickering. It's going to flicker like about 12-13 seconds. I believe the game engine is switching between the resolution to make sure that it supported the 16K video resolution when it's going to confirm, and I emulated